In this video, we are going to tackle about shear deformation. Shear deformation. Our shear deformation is represented as delta x is equal to 1 all over s. S stands for shear modulus. Multiply it with F as force all over area, which is the cross-sectional area A, times the original length or LO of the material, where S is the shear modulus and F is the force applied perpendicularly to the original length and parallel to the cross-sectional area A. Find the mass of the picture hanging from a steel nail as shown, given that the nail bends only at 1.8 micrometer. As you can see on the diagram, we are given with the following. So we have your delta x, or the shear deformation, or change in the conformation of the nail from the original to the bent conformation at delta x is equal to 1.8 micrometer. If we're going to convert that to meters, it is equal to 1.8 times 10 raised to negative 6 meters. And then our original length, so we're going to consider the protruding parts of the nail only, okay, at 5 millimeters or 5 times 10 raised to negative 3 meters. And then the diameter of the nail in meters at 1.5 times 10 raised to negative 3. The shear modulus of the steel is equal to 7.5 times 10 raised to 10 pascals. Now we are required to determine the mass of the picture as m. As we proceed with our solution, to solve mass, solve the force first. Remember that we have the following equation, that force is equal to mass times gravity, and force from the shear modulus equation or shear deformation equation. If we're going to manipulate it, bring out force, this becomes force F is equal to delta X, or the shear deformation, times the S as shear modulus times A, or the cross-sectional area of the material, over the original length of the material. Hence, if we further solve the problem, okay, we're going to consider solving first the cross-sectional area of the nail, which is a fourth of pi multiplied with the diameter squared. If we're going to plug in the values, this gives us 1.7671 times 10 raised to negative 6 meter squared. Plugging in the values for the force, this gives us 1.8 times 10 raised to negative 6 for the shear deformation. This is in meters, times 7.5 times 10 raised to 10 pascals for the shear modulus. Multiply it with the cross-sectional area, 1.7671 times 10 raised to negative 6 meters squared, all over the original length of the nail in meters at 5 times 10 raised to negative 3. Further simplifying the following values gives us your force now is equal to 47.7117 newtons. Or if we're going to solve finally the mass of the picture as m, okay, we're going to divide the force with the gravitational acceleration. So simplifying this one gives us 4.8685 kilograms as our final answer. Hence, the picture is quite heavy. Okay? This is in kilograms. So that ends my presentation for the shear deformation. Our next video tackles about bulk modulus.